All right, so if anyone has any questions, just raise your hand, write it in the Q&A for Zoom, and either Saraf or David's going to stop me, and I'm going to answer your questions. But today, what I'm going to talk about is machine learning simplified for developers with ML.NET. Focus the right screen. I am Jernej Kavka, but you can just call me JK. I am a Microsoft AI MVP, just recently become. I am a SSW Senior Software Architect. You can follow me on Twitter, GitHub, my blog, LinkedIn. I'm one of the organizers for this user group. And primarily, I am a .NET Core and EF Core developer by day. And I'm putting now more and more AI work also for my day work, which is really exciting. So it's no longer a hobby that I do. It's now becoming a real thing. So that's really, really awesome. And I really enjoy that. And this is kind of my, how do you say, the quarantine setup that I'm currently looking at. So I can deliver the presentations to you. And this is you, the audience. I'm using a little robot, our future overload, so that I can watch straight into you. And, if you're interested how you can be a little bit fit without going outside, hopefully this is not going to be something we'll need again, but just in case we'll need, VR has now really good way of getting fit, and I really recommend. I think VR is going to be really good.
Sorry, JK, we have a question actually. What are you trying to do in the previous video? What's the goal?
Here. So here is basically just cutting boxes. So you cut boxes based on the music, and basically it makes you fit because you need to move all around.
Yeah, oh, that's crazy, man. That's quite cool. Thank you.
Yeah, it's really awesome. I mean, you can do all of this in VR without leaving the house. So, if we get another quarantine, there are solutions now. And to finish off introductions, I also have built a Cognitive Studio application written in Blazor. If you're interested in trying out Microsoft Cognitive Services, but you don't want to really build an app for it, you can just use this app and you put your actual subscription in it, all stored in local storage, and you can try out various different things for facial recognition, text analysis, speech, form recognition, and stuff like that. And I'm actually looking for people to help me. So if you're interested in that, let me know. All right. So the way I'm going to do this presentation is we have first my story, why I even went to machine learning, how did I got to ML.NET and solve problems. Then I'm going to step one step back and look at what is machine learning. Now I could show you right away, hey, there's a couple of buttons that you need to click and magically everything works. But what I realized is that most of the people still don't understand what is machine learning. They don't have much appreciation on those couple of button clicks. And this helps you basically understand not just what is machine learning, but how ML.NET allows you to get fast into the machine learning world. And in the end, we'll make a demo. All right, so my story basically became started with something very simple. So I wanted to save money like 15 years ago and even now. And what I wanted to do is I have the description of the transactions and I want to move them, map them into categories. So I can then better understand how much money I spend on each category so that I know, what I need to watch out and how can I save more money over time. And, in high school, what I was trying to do to fill that gap was first I used Excel. and I basically logged every single transaction I have done. I used cache for everything. So basically I took receipts home, entered it in Excel, and then tracked everything through that. So it was a very manual process. Now, after a while, I realized that it's not scalable after months of using that. So, I went to uni, I started to use C#. I was like, yes, let's tackle this. Let's use C#. And I used regex, I used regular just if statements. Then I tried to build my own rule engine. At the end, all of it failed because you still need to manually maintain either the code or the rule engine or the rules. And then you start writing, if you want to automate that, it's essentially starting to write something that resembles machine learning. So I was like, hey, machine learning, that seems like something that could solve this problem. So I then looked at a couple of different machine learning solutions. Back then, when I tried to do this, I did not know about ML.NET. It wasn't even released. And, when I tried it, I realized no one does simply learn machine learning. I started to understand why it was so difficult to learn, or actually at least understand that I won't be able to learn it that easily. And what I found is, one of the problems with machine learning is not just that it's a big rabbit hole, like you're starting to learn it and then they throw you phrases in your face and then they basically expect you to understand a lot of things and that you'll learn all of that stuff. It's kind of like rabbit holes of rabbit holes of rabbit holes. Like you look at one thing, you see a couple of unknown words, you're trying to learn that, and then you realize that that is a completely new subject that you could spend days learning, and that new subject has other things that you could spend days learning. And I really wanted to do this in a weekend or two. And what happened in the end is that I really didn't have enough time to actually do anything. And it ended up as a failed dream. I wasn't able to do much in machine learning. And I thought that was it, that, machine learning isn't for me. So I'll just move on. But about 2 years ago, Microsoft announced ML.NET. And I was like, right, another machine learning thing. I tried it, I've been there, not interested. But then I looked into this one little sentence over here. Without any prior machine learning experience, I was like, okay, I'll give you a shot. And when I looked into ML.NET, what I found is that it's basically a Microsoft machine learning SDK that works offline, which I really love. It's simple yet powerful, like all .NET frameworks should be. It's already been powered by quite a few Microsoft products. As far as I know, it's Office, Power BI, Visual Studio, Azure DevOps. So it's basically, they put the already existing solution that already works in production and then made it publicly available to everyone else. So it's not like a new product that say, hey, let's go do some machine learning. They actually used it in their own products, which is why when it released, it was actually already good from the get-go. It supports some of the major machine learning models like TensorFlow and Onyx. So if you already have a data scientist on your team, you can leverage that. Or if you have an open source project that you want to leverage and they already have pre-built machine learning models, you can use them. And it has one of the best samples I have seen at that time. Actually, because of how easy the samples were, they were the reason why I went back into machine learning and not just use it, but also teach it. And just to tease you a little bit, I actually achieved my goal. I was able to build a solution that was able to essentially categorize all of my bank transactions. And because of how the samples were done, specifically the GitHub issue classifier, it took me 1 hour. And I was just like, that cannot be it. That cannot be that easy. And it was. I mean, I had to clean up the data and stuff like that later. But man, I had my first prototype that worked pretty good in 1 hour. And there's very few machine learning frameworks at that time. And even now, that can get you to that point in a single hour. So, okay, now I hopefully hooked you into what is ML.NET and make you want to learn it. I will make a step back and I'm going to show you what is machine learning, because this may give you a bit more appreciation what ML.NET does, as well as understanding what machine learning actually is a little bit more simpler. I won't go into formulas and all of those crazy stuff. I'm going to go really high level, what you need to know as a developer, what machine learning is. So what is machine learning? Now, from developer perspective, in classical programming, we get spec review, like this is the spec, this is how the application has to work, and this is the data. So we based on those two parameters, we write an algorithm. And then once we put data in, we process that and we get an answer. Simple, right? But the thing is, you need to know the rules ahead of time. Now with machine learning, it's a little bit reverse. So we have all of the data, not all, most of the data, a really good segment of the data. And we also have the answers for the data. We throw all of that into machine learning, and then we get rules for those two parameters. So it's basically like flipping around how you basically try to solve a problem. Now, to give you an example, a really simple one is rock, paper, scissors. So in the classical programming, what you would do is an if statement like if rock, then paper. If paper, then scissors. If scissors, then rock. It's a very simple logic, and this is how you determine who won. However, in machine learning, what you do is, or essentially a Excel sheet where on one column, for instance, you say, hey, if opponent does this, you're the winner if you have this. And what you might notice over here is that I actually have some repeated cases. And with machine learning, that is very common. You might have a lot of data that repeats itself, and you can look at this like basically reinforcing that, saying, hey, this is true in a sense. So you will, in the machine learning data sets, you will very frequently see a lot of duplications or similar data. And the really big advantage of machine learning is if you want to basically extend this and not wanting to actually learn the rules. So if I try to do rock, paper, scissors, lizard, Spock, I could try to basically write a program that follows the rules, who wins when. But what it can do instead is just write down all of the games that have happened, and just remember the ones that were winning combinations, and the machine learning will know how to play rock, paper, scissors, lizard, Spock without actually teaching it. It will understand roughly the rules based on the Excel sheet that you give it from which it's going to learn. So this is kind of the advantage of machine learning. You don't have to specifically teach it to understand rules. And once you have a machine learning model, how does actually the operation works for ML? You call it ML ops, which which like a DevOps. So first we start with training data, and then we use a machine learning training algorithm. We feed all of that data, and at the end we get a model. So that model is kind of like a decision algorithm where, based on all of the knowledge it gained, it knows the answer. So you put in a question and it can transform it into an answer. Now, once we have a model, we need to deploy this model to various target devices like desktop and mobile clients, web servers like web APIs, and also IoT, like we have Azure IoT, for instance. And this is not where the story ends for the machine learning ops. When the users are using and IoT is gathering information about the environment, devices, and stuff like that, we're getting back feedback. Either users telling certain things are wrong, or when we're getting temperature from different devices, different times, different things happening, we're getting that feedback. And what we can then do is to improve the data we already have, do maybe a little bit of cleanup the data we're getting back, and then we can feed that back into the training data and repeat the cycle. And this is how we can improve machine learning over time, is by gathering the feedback and then improving the training data set we have and retrain it, redeploying the model, which can be just a zip file, to all of the clients, and then repeat that. Now we've kind of seen roughly what machine learning is. We've seen how the life cycle would be for the machine learning, but what is the machine learning on its own? So this black box is a little bit hard to explain, because machine learning isn't just one thing. It's just like asking, hey, what is programming? And then you start talking about, say, functional programming. Well, functional programming is a subset of programming. And similar thing happens here with machine learning. It's not just one single thing. Now, one of the popular divisions of machine learning is, for instance, supervised learning, or what some called labeled data. So this is one thing that you might want to start with. And one of the simpler subdivision of that would be classification. Now, for instance, binary classification is a simple, like, is a tweet positive or not? You have yes, no, and for certain things, you can even have a range between those two values. So it doesn't have to be quite binary. It could be a range between 0 and 1. Then we have something like multi-class classification, which could be used either for image classification, or could be used for if you have properties of fruits, to basically trying to figure out what that fruit is based on those properties and things like that. And for simpler multi-class classifications, for instance, you have a decision tree behind the scenes. You could even have, for instance, what type of loan somebody can have based on what, based on all of their properties of that person. Now, then we have regression. So regression, for instance, is if you want to predict prices of houses. Now, this isn't quite forecasting houses. We are not trying to forecast the price in the future. We're saying, this house is in this area, it has 2 bedrooms, and for instance, it has easy access to school, but doesn't have public transport. So then the machine learning would try to guess what would be the cost or rent of that house. Now, then we have unsupervised learning, or some call this unlabeled data. This one is a little bit more advanced. And what essentially that means is that we don't necessarily have data backed with specific answers. We basically are kind of looking at a data and saying, hey, I want to learn something about this data, or I want to learn answers as a relationship between different kind of data. One of the simpler examples of that would be clustering. So for instance, product recommendation is one part of clustering. And I think, let me check if we have any questions. I don't think we have. So one of the easiest example is product recommendation, where we're trying to make clusters of similar customers, and then we can say, okay, all of these customers have bought this, so maybe this person that is part of this cluster might also be interested in buying that particular product. That is the simplest explanation of that. Then we have dimension reduction, which could be used for, say, Power BI, where we have a lot of graphs, statistics and stuff like that. What we're trying to do is, imagine we have a table with a lot of columns and a lot of rows. And dimension reduction kind of can give us a little bit more sense of the data and try to get the most valuable information from that data. That would be the most simplest example of dimension reduction. And then we have reinforced learning. So reinforced learning is a very interesting one, and it's one that is recently more and more popular. And basically, it's kind of an on-the-fly learning. It tries something, it will likely fail, it learns from the failure, and then it repeats the whole cycle. So that is basically used for self-driving cars, for robotics, and gaming. As well, it's now used a lot for making houses more effective, layouts of cities and stuff like that. Things that, you know, can change really quickly based on things that you do. It's a more reactive machine learning. All right, so there's a lot of things here. And even though it looks a lot, this is just a small subset of what machine learning is. Imagine like explaining what programming is and then just say, yeah, we have functional programming, and then we have this classical programming, that's for C++, structured programming, and, you know, you stay at that, like not even mentioning scripting and all of that stuff. Similar thing is here. We're just scraping the surface. But let's zoom in a little bit on one of the sections to better understand what actually means if we look into multi-class classification. What if we want to learn this? What do we need to know? Now, if we zoom in, what happens is each of these bubbles have their own machine learning trainers, their own set. And the multi-class classification trainer has a couple of trainers that you can use to create a model out of your data. Now, you can read more in details from documentation of Microsoft, and there's a lot of stuff available on the internet. But what you should know is that each individual trainer has their own advantages depending on how big is your data set, how much your data is repeating, how many different categories you need to predict, the categories large or small. So all of these things impact which of the trainers would be the best for your machine learning. And there are even guides where you have this huge graph where it shows you how to find the best trainers for your machine learning. And I won't go into details here, and there's no need to learn this, at least not now. But just to give you a little bit of insight. Why does it take so long to actually learn machine learning? Now let's go back to this nice tree of machine learning. If we think about what ML.NET is trying to do, is it tries to replace the black box with already pre-built algorithms, so you don't have to learn the specific algorithms for training machine learning. That is done for you. And one of the bad things, one of my favorite machine learning type, unfortunately, is not supported, the reinforced learning, but hopefully we'll get that sometimes in the future. Now, how do we now start? Like, you have seen that huge tree of machine learning. So how do I actually start? How do I even know where to look to get a machine learning project running? So you start with a scenario. So what are scenarios? For instance, you want to figure out, is a tweet positive or not? You use a binary classification, trying to do bank categorization. You use multi-class classification. You're trying to predict house prices. You do regression, and so on and so forth. And for instance, product recommendation, we do clustering. Do we have a question? Daniel, can you please mute? Thank you. All right, so there are a few caveats to what I all said. So machine learning won't magically solve all your problems. And what I mean by that is, if you do not understand your data, there's a good chance that your machine learning model won't work well. And what we will find is that we kind of need to guide machine learning toward the right solution. Now, this sounds like counterproductive. Aren't we using machine learning because we don't know the solution? Kinda. It's basically, we try to find solution for a few cases that we know that should work, and then we make sure that all of that is working. We try to make sure that the extremes are working correctly, and that we roughly understand how the machine learning is working, so that for all of the cases that it would be humanly impossible to write all of the rules, all of the programs, all of the algorithms to capture them quite with quite good accuracy and confidence working correctly. So we're not talking about trying to solve a small problem. We're talking about solving big problems with a lot of data, with a lot of rules, as well as things that are changing over time. And you're just trying to make sure that the machine learning is correctly learning new information. So I suggest that you start with something like multi-class classification or binary classification, just to get a feel how machine learning is learning and what you need to watch out when you're doing things. But don't worry, I'll show you a lot of things in the demo. So, all right, this is machine learning. And what I'm going to now show you how we can use ML.NET, what ML.NET is, and how can it help us to get to a solution. So when we start with ML.NET, we have all of these different scenarios. Basically, ML.NET wants us to start with the scenarios. So we have a lot of different scenarios, and this is a pretty old screenshot. Now I think they have a lot more scenarios than this. And what ML.NET does in nutshell is replacing the training algorithms with something we don't have to implement, and we just need to know a couple of parameters. Now, there is one little problem that I have with this, is we kind of still need to know which trainer is right. And I don't think that's something I would be willing to learn. I mean, yeah, later once it works, but not out of the bat. So if you're not interested into looking in depth in those trainers, there's something called ML.NET Model Builder. And this is really, really good start, because this is kind of like a wizard that is built on top of ML.NET SDK in Visual Studio. And now it's also available in VS Code, in Console as a CLI, and they're probably going to add more platforms to support. And what it does, it basically tries to pick the best trainer for the given scenario, as well as data. And this can change over time because your data changes over time, and it might find a better trainer than what it used to be a good trainer for your data. And what it also allows us to do is quick prototyping, which is I'm going to show you very soon. So to get started, we go to the, you can Google just ML.NET Model Builder. I have a URL down below over here. And if you're interested, I can share the URL at the end. And unfortunately, if you have an older version and you upgrade it, and this, in some cases, you need to go preview features and enable it from here. They have changed the way you install it over time. I think now it should be just fine to go to ML.NET Model Builder and click download. But if it's not, you can enable it through here. And now let's get the demo started. Now that we know that. So before I go to Visual Studio, I need one thing, and that's data. So my training data is coming from a real bank that has been imported into an app called Tushel, which basically allowed me to classify all of the bank transactions for the last 4 years. Yeah, about 4 years manually. So at the end, I was able to export this as a CSV. So this is how the CSV looks like. We have several columns like date, account, categories. That's the thing we are interested in. Now we also have tags. And this is going to be a tricky thing to use because this is something we also manually enter. And we cannot use this as an input because it was something that I manually entered. If we have this, we would already know the categories. And that's going to be an interesting problem. Then we have expenses, income, currency, and at the end, we have description. That is going to be the most important part over here. So this is going to tell us what the category should be. All right, finally, demo. Need to drink a little bit. Do we have any questions so far? I assume not. All right. So let me get started. So I'll create a new project. I'll just start with a console application. Now you can try to search for machine learning. You won't find anything. You can try to search for ML. You won't find anything. So this is not a type. This is not a type of project. So what we need to do in order to use this, we need to create a new project first. I'm going to just do console application Brisbane. Let's do 2020-Brisbane AI-MLNet. So we have that all right. That's all fine. Let's create this.
JK, I've got a quick question for you.
Yeah. You're a little bit quiet.
My question is more around, okay, so you've got ML.NET and obviously you've got Azure services that deal with ML. Mm-hmm. In what scenario would you use ML.NET compared to some of the other services in Azure directly?
So I found ML.NET a better start than most of the solutions so far. It is just for a lot of people that I have shown this and a lot of projects that I had, it's just the easiest start. Now, once you get into more complicated things where you need to have deep learning with neural networks and stuff like that, you're starting to get into areas where something like Azure ML would be a better choice, which is, as far as I remember, predominantly neural networks. Like ML.NET looks like it uses a lot of neural networks, but the truth is that most of the algorithms are actually much more simpler than that. It does not use a neural network by default.
Okay, thank you. We've got one more question in chat. So
Yes.
and I apologize if I'm pronouncing this wrong, but it's on key law. Wants to know, is this like C#?
Yes, it is a NuGet package for C#, and you can also use it with F#, and it also has a CLI. So technically speaking, you could use anything that can call EXEs or whatever you can do in Linux and Mac. Anything that can use CLI could use ML.NET. All right, so let's get started. So you need to have a project, and you need to go right-click, add a machine learning. Now, if you try to do this on the solution, you won't get machine learning. Now we click this, and now we get this view. Yeah, that's a little bit better. So here we start with the scenario. So you need to roughly know what you want to build before you jump in machine learning. And here we have text classification. It's a little bit unfortunate name because this encapsulates not just the multi-class classification, but also binary classification. So if you're looking for binary classification, this is it. Then value prediction is regression. So this is not a forecast. This is just looking at various attributes and trying to guess a number. Say, price of a house based on how many bedrooms it has, how many bathrooms, and stuff like that. Then we have image classification, recommendation, object detection. If anyone is interested in the difference between image classification and object detection, image classification just looks at the entire picture and says if something is in it or not, whereas object detection tells you where that object is that it found. That's the major difference. And down below, we have limited scenarios. So these are the scenarios that you actually need to go to GitHub, clone the repos, and make code changes. So up above, you don't need to write any code to test it out. And down below, you'll have to. Now, I'm going to quickly just show you a few of the scenarios, just the first step. So if I go to image classification, what you'll see on the environment is we have the option to go local CPU. So that's going to hammer your CPU really hard. Then we have the GPU. You need to install an extension. Once you have that extension, you can use your GPU to do model training faster. And if you don't have a strong machine, you can also use Azure. So this can provision a new workspace for machine learning, and you can train it on Azure. So as far as I know, this is not quite the same as Azure Machine Learning. Now, if we go, for instance, object detection, this one, for instance, only supports Azure, and everything else currently only supports CPU. That's why I wanted to show you different scenarios, just to, if anyone is curious about the environments, that's how it works. All right, so let's go CPU. Now the next step is to select the data we want to process. So you have the option of file. So you can have CSV, TSV, or TXT. Now TXT has to be formatted like CSV or TSV. So you can just bring any text file. And you also have support for SQL Server. So in my case, I have a CSV. But for a SQL Server, other than connection string, everything else is the same. So I'm going to go for the from bank unfiltered. And once it's loaded, down below, we have the actual table with first 10 results. And over here, we have the column that we want to predict. I want to predict categories. And I'm going to show you some advanced data options a little bit later. I'm going to next step. Now here we are at the most difficult part. Press start training. Now, if I start training, depending on the data set and how strong your machine is, you might get something like this. Training time finished without any model trained. This means that you haven't given the machine enough time to actually train a model. And if you're in doubt, like if I go to I, you don't really see, it doesn't give you instructions on how long to give training time and stuff like that. You could click this URL up here, but if you forget things, you can just put it on 0 and you get this error where it actually tells you what are the recommended numbers. Now, I currently found that especially when I'm screen sharing, my machine is a little bit slow. So what I'm going to do is I'm going to put 90 seconds. So I'll give my machine enough time to try out different trainers. If you remember, the multi-class classification had like 7 different trainers, and the first trainer that it tried to use is average perceptron. I think it's 1 versus all. Is this over? I think, if I remember correctly. And now what it basically tries is, based on different parameters from your data, it tries to figure out which the training algorithms would be the best. It orders them from likely the best to likely the worst, and then it executes them. So there's a good chance that the first training model, first training algorithm that it will select will be already the best one for your problem. So we have the next one. This one took quite a bit. And what is currently happening is also very interesting. So right now it's reading the Excel, but it's not using the entire Excel for training. So what happens is it actually splits your Excel into 2 parts randomly. And it uses 1 part for training and 1 part for evaluation. Hide this. So these percentages over here are basically, how accurate was the training half versus the evaluation. So it did the training, it ran the training algorithm against the training half. And then once it got a model, it went through all of the second part for evaluation. And the number that we get down below is how many times it got it wrong. So 96% in my experience means that either your data set is really good or there's a problem with it. It's usually too high in a lot of cases, especially on the first try. And if we go to evaluate, what I notice is here we can basically have all of the inputs. We have predict button, and on the right, we get the results. me hide this so we have a little bit more space. We have here all of the inputs, and here we have all of the results. Now, the problem that I see is this. So tags is something that I entered manually. That means that if I get a transaction from the bank, this thing is going to be always blank. Now, what I'm suspecting is that the current machine learning model is strongly associating tag with the category because they're almost one-to-one relationship. And that's why we're having such a good result. But as I said, we cannot use this in production because we already need to know the answer to get the right category. So that is not really useful. So how can we solve this? Now you can go to Excel and actually remove the column. So we don't have tags. There's also another option that you merge the category and tags. So you're trying to actually guess the both at the same time. But right now, I'm perfectly happy to just try to guess the right category. So what I'm going to do is I'm going to go back to data. I'm going to advanced data options. And over here, I'm actually seeing all of the columns and the options that we currently have. So what I'm going to do right now is I'm going for tags, ignore, save. I'm going to go train. Now the previous, the first machine learning algorithm, I think it took, this one, it took 48 seconds. I don't want to wait that long. This one is good enough. Out of experience, I know this one is good enough. So we'll just train long enough to get this one. In practice, you would try to get the best one, which in this case is actually the second one, which doesn't happen that often. And now, okay, already trained. There's a box in, seems like it when I did training and actually went to data tab rather than evaluation. But what we can see here is that the accuracy dropped by 6%. So that means that that tags contributed 6% of accuracy, but we couldn't actually use this in production. So this looks a little bit better. So we have a question. So we're saying that with the multi-class training, having two different classification, example, category, tags, column, can either skew the results or make them more perfect. So what you can do is you can literally make one machine learning that only tries to figure out category. And then you can have literally a model for each of the category to guess a specific tag. So basically, for instance, if you have a category of, say, accommodation, you can have a model that is specialized in only tagging transactions of category accommodations, or you can split them into, say, just having two models where one is just responsible for categories and another one just for tags. But the second one already gets categories as an input. So you have a little bit more general purpose way of classifying tags. Or you can do something like what I did for my own personal use, is I actually merged the two columns into one. So I basically have category space dash space tag. Now, this may not work all of the times, especially if you're starting to get a lot of variation. either a lot of variation, or it starts to become very ambiguous or too specific, like you overtrain your machine learning to just look at things too narrowly. And then when it gets a category wrong, it doesn't get only the category wrong, it also gets the tag wrong. And then you might get a completely out of the park result. So I would recommend to limit the amount of error your machine learning can do. So for instance, just try to recognize category first, and based on that result, try to do tagging. Because if you miss with a tag, that's fine, because the category might still be correct. Does that kind of make sense? Hopefully it does. So let's go back to the sample data. So right now we lost about 6% of accuracy. And I can tell you that we can get back some of the accuracy back. What I'm looking here is date. Now, date is very useful when you do forecasting. When you do classification, the exact date is actually really, really bad. Now, we could go into data science why it's bad, but I'll just tell you it's bad. Now, better than date is a range, like saying summer, winter, Monday, Friday, Wednesday, or weekend or work day, something that might capture a lot more transaction, a lot more rows than just one particular instance. But you set something that is only happening, for instance, on Sunday, and then you can say, okay, when the person went to coffee shop on Sunday, they had breakfast and they tagged the transaction as food, but then when they went on Monday, it was actually tagged as coffee, because on Monday they don't eat breakfast at the coffee shop, at the same coffee shop, they're going for coffee. So in this case, the day of the week would be useful for classification, where you can then be a little bit more precise with the tagging. But the date specifically does not help, or time specifically. You need to look at them a little bit broader range. And this kind of confirms when I go to advanced data option. And when I look at the date, we don't even have a type date in the multi-class classification, because it doesn't actually make sense when you look at the data science. So what I'm just going to do is ignore it, because we don't need it. So let's do a quick train. Now, for anyone who is using Linux or Mac, there's actually a ML.NET CLI called AutoML, and you can run everything in the command line. Also in Windows, if you like, and if you use a VS Code ML.NET Model Builder extension, it uses the same AutoML CLI. In fact, this UI also used the same CLI. So the thing that you're seeing over here, that is actually AutoML CLI behind the scenes. All right, so if you look at the accuracy, oh, that's surprising. Usually it bumps up by 1%, but in this case, we have 1% lower. That sometimes happens because it takes random 50% slice. So this 50% slice might just happen to reduce our accuracy, or the previous slice happened to increase the accuracy. Now, rule of thumb, if your accuracy is jumping a lot, then there's a problem for it. And I'll talk about once I got this covered. Now, what I want to show you next is one interesting thing is when you look at this data over here, we can improve things quite a bit. Not to go too much into details, we have here income amount. And if we look at income amount, we have categorical. And to explain you what all of these things does, categorical means that the value is being hashed and it doesn't expect to be too many variations. Like for instance, for account, there are only 2 different values, so it set it as categorical. And then for instance, income amount, even though you would think it's a numerical value, it set it to be categorical because there's only one value. So you can think of that it's considering it more as a true false value rather than a number. Then we have currency and main currency, which is always fixed Australian dollars. So that is also categorical. And what I'm going to do is I'm just going to ignore all of the categoricals, except for account for now, because they actually don't give us any value. Because in currency, all of them are Australian dollars. In main currency, all of them are Australian dollars. In income amount, everything is 0. In fact, the in main currency over here is a carbon copy of expense amount. So what I can just do is ignore, because it's the same column. It doesn't give the machine learning any new information to work with to have a better chance to understand how to get to a category, how to correctly predict category. So now that I save, we have a significantly better model. It's much simpler to look at. Less input sometimes actually means better results. Also, when you build a UI for your clients, the less they need to enter, the better. Also, you can see here our time to train also is getting lower and lower. So we can basically get more training models for less amount of time. Now, what I found interesting is that the accuracy actually changed. That is actually fascinating. They seem to have updated the algorithms, training algorithms, but in the past, when I was doing demos, the percentage never dropped. So because all of the columns were redundant, they haven't changed. However, I think the reason why we are getting much more, a lot more difference in the accuracy is because they changed a very important part. So in the past, the description was categorical, and now it's correctly text. That was a bug that I reported 2 years ago, and they finally fixed it. And categorical was a lot more stable in accuracy, and text is a little bit less stable, but it gives us a much more high accuracy. So in the past, I usually get around 85% when this is categorical, but now it's much higher because it's the correct column type. And what text does compared to categorical is text splits up the string. Imagine it splits up by space, and then it saves each individual part, and then it tries to find the relationship of those split text with all of the other columns against the category, which means that if you have a word, for instance, coffee, in your description, and that coffee repeats itself a couple of times from various transactions, it will start to match the actual word coffee with, say, a category restaurant, rather than look at the description as a whole. So this is why text is more correct, especially because when you have the transaction description, you have a lot of different numbers and city and all of that different stuff that actually does not impact in categorizing the actual category. Now, I'm not trying to go too deep because I have spent quite a bit of explaining. I'm going to ignore account. Simple reason why is because account is either credit or debit card. And I don't want the accuracy to get reduced just when I switch from debit to credit card or even from INZ to a different bank. I don't want this to impact the accuracy. So I will lose a little bit of accuracy now in order to get a more long-term accuracy, making my model more resilient. So if we train this, we should get, yeah, actually it's roughly the same accuracy. We didn't even lose any accuracy. So yeah, it wasn't even that important in the end. It used to be more important when text was categorical. And this update actually came very, very recently. That's why I don't know exactly what the results are going to be. This feature where you can actually specify exactly their column type. In the past, you could just ignore them. You couldn't set up specific values. Now, the last thing before we generate the model is this looks like a okay model, right? We have a really good one. Like we have only 2 inputs trying to predict 1 output. And if I try to do this, we have nice 84%. I try to remove all of this noise and it still recognizes the right thing. And if I get my cheat sheet, give me a moment. I go that snippets, open with VS Code. Yes, and say I want to try this one, which should be coffee. You can see that it actually recognizes this to be food and drinks, which in my case would be under category coffee. In fact, I can remove this part and it should still work. Yeah, it's pretty sure that that's food and drinks. And that's because in my case, there is an American concepts of which is a coffee shop. Now, there is one interesting problem with this model. Now, if I start bumping a numbers to expense amount and start predicting, this looks all right, right? Now add a new 0, and I'm starting to get in territory where I myself don't know how the model is going to behave. Yeah, so now all of a sudden, we're getting a weird result. I just added a couple of zeros, and all of a sudden, it thinks that it's either health or personal care, reconciliation, maybe it could be transfer, maybe it could be charity, maybe it's clothes, but not food. Like food is less than 1% accuracy. It's like 1% confidence. It's like, it doesn't even look at description. And the reason why this happens is because my data, especially the expense amount, is highly biased at higher values toward those categories. So that means that any high value, it will only look at these categories. And because the American concept doesn't match with any of those categories, it's just like, it's one of those probably. So it is important to test all of the extremes. before you push into production. And sometimes amounts, they sound like a good idea, but test if they actually are required. Like, you will probably find some models that will need to have numeric values. And you just need to make sure they work nicely in different ranges. But what I found in my particular case is that I can simply ignore it because it gives me almost the same accuracy. So what I end up having is, once I optimized my model, I only lost a few % of confidence to have a very accurate model for what I'm using, like 89%. That means that theoretically, it means that 10% of the time it's wrong. But think about that my data have conflicts. So there's certain things that I personally have not correctly classified. So that's part of the 10%. And there are some of the transactions that are ambiguous, and even I would know exactly how to classify them correctly. So that's also part of that 10%. And also another thing that a lot of people miss when we look at these numbers is how many times in production would actually be wrong. If the 10% of the mistake happens less than 1%, then maybe this is a perfect model. Maybe you don't need to make any changes. However, if those 10% happens, say 90% of the time, then this is a terrible model. This is worse than doing nothing. So you have to put these numbers into perspective. They might not exactly represent how many times it might be wrong in production. So this is something to keep in mind. And now we have a really nice model of just one input. And I really love it. So you can just get a couple of things over here just for testing. This one should be investment. I can remove most of the stuff and it just works. And keep in mind, this is very little data science done on actual data, and it just works. And in your case, you might have a similar experience, or you might actually need a lot more cleanup of the data. Now, what I'm going to do is add a solution. And now we finally come to the code. Now, what I'm going to do is I'm going to select the .console app as the startup project. And I'm going to first look at the project .model. So it will generate two projects based on the name of the original project from which you did right-click, add machine learning. And what we have here is the model I input. And here we have all of the columns that have been defined. Now it's going to include the ignored one as well, because you have the option to do retraining based on the original CSV. So it needs to be able to read the entire original document to be able to then retrain itself. Then we have model output, which has the prediction, which is string in this case, and also gives a score, a array of score, which is a percentage of every single possible category, how confident it is. I'm going to show this later. Then we have the consume model. This is something you can just use in your project, make a new instance of consume model, and then just run the method predict, and this is just going to create the prediction engine, which is the thing that will do the actual prediction and return your result. Now, if you're doing dependency injection, the ML context is thread safe, However, and the model is also thread safe, the prediction engine is not. So you can do dependency injection on the I transformer, but you should not make this singleton. You can make it per request, for instance, the prediction engine, if you do dependency injection. Now you can see there's very little code over here, and that's actually all there is for machine learning. And the console app is actually an example of the machine learning, how you use it. So here what we can see is it manually created a model input as a sample data. It hard-coded the first transaction, and this is all it required to do the prediction. So the result is prediction result, which you can see here. It outputs the string, which is the predicted category. And over here, it shows all of the scores. So let me show you how this looks like. So here is the predicted category. The question marks are emojis. So it wasn't able to render the emojis correctly. And over here are the confidences. Now, to better understand what these numbers are, I have actually a snippet. And I am going to copy this part and replace it with all of the outputs. I need to resolve the link. And what this does is just makes the output a little bit simpler. So now we can see, okay, these scores are, are actually the categories, and how confident it is that that category is correct. So for instance, if I take this one again, and run it, it now selects the investment, which is down here. So invest. And how do you get this list in the right order? So when you have, let me open up the Excel. When you have Excel, what you can do is go under data, make it, what was it, insert? Table. And then just copy based on first occurrences. So that's how you get the right order of the score. So basically this is the same as the first occurrence in the original Excel. So if you want to do this, then this is how you want to do it. All right, so this is it for this demo. Now, if you're using Linux or other tools, other operating system, or you want to do DevOps, I encourage you to look at Auto ML CLI. You can easily install it via .NET tool install -g ml.net. And here's just an example of the output, and it will include the zip file. So you can actually just take the zip file out and use it as an artifact for your web API or other applications, or you can just use the generated application or project. And I also have an example of how you can use ML.NET in Blazor client side. So just to quickly show you, this is a real thing. You have this Blazor application over here. Even if you go to network pane, if I run this, what we have here is it downloads the model zip. It also downloads the training JSON, but this is mostly used for displaying the categories in the right order. And you can use this as a live demo running all in the browser to basically do classification, regression, and all of that stuff. And this all works offline. So it's really, really awesome. I really love that feature. And to summarize everything, I've shown you how to import CSV. I have shown you how to tweak columns, and with a bit of data science, how to get better results, at least on long term, how we generate project with machine learning, and how we can run it everywhere. There's an interview that Richard Campbell did with me about more in detail how this helps developers to get to better solutions. And I did manage to achieve the goal that I set, and it's working. Thanks.